The following questions refer to the below molecules. Which of the following molecules have the largest dipole moments? So when we're looking at dipole moments, we need to look at two things. One, the bond polarity. And bond polarity, in general, is just difference in electronegativity between atoms. And then we also need to look at the molecular geometry, because if it's symmetrical, the dipole movements will actually cancel out. So I already drew the Lewis structures just to save time. We forgot the H. So let's look at three of them. So A, CO2. So I know CO2 is linear, so that means it's actually symmetrical. So that means that oxygen is actually more electronegative, right? Because it's more to the right. That means it has more protons. So that means the dipole moment will be going towards the oxygen. But since it's linear, it practically cancels out. So that basically means that there is no net dipole movement, so it can't be A. Now I'm going to look at H2O. H2O has a bent shape, okay? So that means it is not like symmetrical. And the dipole movement will be going towards the oxygen, and it's a very big dipole movement because there's a large electronegativity difference between the hydrogen and oxygen. So that looks like a good choice. I now have CH4, which is tetrahedral, so once again it's symmetrical, and the dipole movement will be going towards the carbons for all of them. And since it's symmetrical, they practically just cancel out. Why did not change color? It doesn't change the dipole movement. So actually the net dipole movement would actually be 0 once again. And now if we look at C2H4, this is a planar molecule, so that's planar. And once again, if you just look at it, the carbon and the hydrogen and the carbon double bond, it's supposed to be double bond. And the carbon double bond is actually slightly polar, but overall, there's not a very large dipole movement compared to water, so it won't be D. And then finally, pH3, which is a trigonal pyramidal shape. So if we just look at it, there's obviously a difference in, it's not symmetrical, right? So there is a dipole movement, but if I compare P and H with O and H, the pH compared to the HO, has a less bigger of a difference between the electronegativity. So that can't be the correct answer, so B.